Hey, welcome to my YouTube channel. Today we are going to find the winner of a circular game. There are n friends that are playing a game. The friends are sitting in a circle and are numbered from 1 to n in a clockwise order. More formally, moving clockwise from IF friend brings you to the I plus 1 friend for I between 1 and n, and moving clockwise from the nth friend brings you to the first friend. The rules of the game are as follows. First, we start with the first friend. Then we count the k next friends in the clockwise direction, including the friend you start at. The counting wraps around the circle and may count some friend more than once. The last friend you counted leave the circle and lose the game. If there are still more than one friend in the circle, go back to step 2, starting from the friend immediately clockwise of the friend who just lost, and repeat. Else, the last friend in the circle wins the game. Given the number of friends n and an integer k, we are requested to return the winner of the game. In example 1, we have n equal to 5 and k equal to 2. Starting from the first friend, since k equal to 2, the second friend gets eliminated. Since we start at friend 3, then the next friend which will be eliminated will be 4. If 4 is eliminated, we start counting from 5 and 1 will be eliminated, so on and so forth. Then at the end, you are left with friend 3. So the answer is 3. We can see this problem derived from the Josephus problem or Josephus permutation. It's a very well-known theoretical problem related to certain counting out game, such as you have to pick a person from a group, meaning any more. So this is the historical behind the problem. You can see they are talking about Josephus, which is a Jew historian living in the first century. So to solve this problem, right, we need to break it down. So what we can notice is we can see the function. Let's consider f and k, the position of the survivor, So after the kth person is killed, we have a circle of n minus 1 remains. And the next count starts with the person. The number in the original problem was k modulus n plus 1. The position of the survivor on the remaining circle will be n minus 1 k if counting is starting at 1 or at the first friend. To shift it, we need to start at k modulus m plus 1. This is for the recurrence. So fn will be fn n minus 1 k plus k minus 1 mod m plus 1. With a fn given one person remains and k is equal to 1. So we can simplify this to be written as g of n given m equal to g of n minus 1, you have n minus 1 remaining in the circle, given k count plus k mod m. So to solve this problem, then we can use recursion. So let's see the coding part. So we are calling the function, we are adding this one for the initial person. So it will be the winner helper, this function. If n, we have n equal to 1, we are returning 0. So but if it is not the case, we're returning the helper winner of n minus 1. So one person has been eliminated, given kcon plus k mod m, as we have seen the simplified function was. So then we return, it will be a recursive call. So we return that 1 plus 1. So that will be the answer. So let's run it. So the idea is, let's say we are having this the first count, right? So we'll be calling winner helper of n 5 and 3. Sorry, 5 and k equal to 2. So we are calling that one for this first. Then that function will call this one, and that function also will call this one, and so on and so forth. At the end, will be here when n equal to 1, so that will return. Since it is a function call, a recursive call, when you reach the end, then we'll be calling from the stack. So the run complexity will be O of n. The space complexity will also be O of n, since you're using the stack code. So let's submit it. Please share, subscribe,